Hello everyone, welcome to the Networking Lab. Subnetting is one topic that trips up most of the CCNA beginners. Students either completely avoid it or spend weeks trying to wrap their heads around it. But I'm going to tell you a secret. Subnetting is actually really straightforward once you understand just two formulas. In this video, I'm going to take you from absolutely zero to confidently subnetting any network. By the end of this, you'll be able to look at an IP address and the prefix length and instantly know how many hosts it supports, how many subnets you have, and what every address in that range means. This is everything you need for your CCNA exam and for real-world networking. So let's get into it. So here's our game plan for today. We have 7 sections. We'll start with what subnetting actually is and why it exists. Then we'll cover IP addresses and CIDR notation. After that, we'll break down how subnet masks work at the binary level. Then the good part, the magic formulas. 2 formulas, memorize those and you can answer most of the questions. Then we'll walk through a full subnetting example book step by step. Next, we will build a subnetting table and introduce to VLSM, variable and subnetting mask. And we'll close up with a cheat sheet and some practice problems so that you can test yourself. So what exactly is subnetting? Subnetting is a process of dividing one large network into smaller, more manageable subnetworks called subnets. Think of it like you own a building and building has one street address, but inside you have different floors. Floor 1 is the sales team, floor 2 is the IT department, and floor 3 is the HR department. Each floor is a subnet. Same building, same IP, but divided into separate segments that can talk to each other without going through a router. Just like people on different floors can talk, can't just walk through the walls to get to each other. Why does this matters? First, it reduces network congestion. Broadcast traffic stays inside its own subnet instead of flooding the whole network. Second, security. You can control subnets. Which subnets can talk to each other. Your guest Wi-Fi should not be able to reach to the financial server subnet. Third, the efficient IP usage. Instead of wasting hundreds of IP on a network and only need 5, Subnet lets you right size each segment. And fourth, this is very important right now, subnetting is a core skill tested in CCNA exam. Before we submit anything, we need to understand IP addresses and their classes and the CIDR notation. Historically, IP addresses were divided into classes. Class A would cover IP addresses from 1 to 126. These were designed for huge organizations with millions of hosts. Class B would cover 128 to 191 for medium-sized businesses, and Class C covers 192 to 23 smaller networks. You will hear about Class D for multicast and Class E, which is reserved for research. For subnetting, we'll mostly work with Class A, B, and C. The next thing we need to know is CIDR, which is classless interdomain routing. Is the modern way we write subnet information. Instead of saying the subnet mask of 255.0.0.0, we'll say /8.
Okay, so this is the most important slide in this whole video. So there are two formulas. Formula 1 is used to calculate the number of usable hosts per subnet, 2 to the raised power h minus 2, where h is the number of host bits. Example, if we use /26, so that means we have 6 bits, host bits actually. So 2 to the power 6 is 64 minus 2 is 62. Okay, so let's do another example using the same formula. So if we have to calculate /28, number of hosts using /28. How we do that? So it's /28, number of hosts. /28 means 28 bits are reserved for network portion. Remaining 4 bits are reserved for host portion. So you use the same formula to calculate the number of hosts. 2 to the power 4 minus 2 is equals to the number of hosts. 2 to the power 4 is 16 minus 2 is equals to 40. So there are 40 number of hosts using /28. Here, an important thing is, why do we need to subtract 2? It's because first address in every subnet is the network address. It is used to identify the subnet itself, and the last address is the broadcast address used to send traffic to all the devices in the subnet. So neither of those can be assigned to a device. So that's why we subtract 2 from the number of hosts. So the formula number 2 is to calculate the number of subnets. So 2 to the power of n, where n is the number of bits borrowed from the host portion. So if you borrow 2 bits, so 2 to the power 2 is 4. If you borrow 3 bits, 2 to the power 3 is 8. If you borrow 4 bits, 2 to the power 4 is 16. So let's use our previous example to calculate the number of subnets here. Okay, so in /28 we have 4 bits that we have borrowed from the hosts. These are host bits. So in total we have 32 bits, right? So that means this is a network portion. So we have borrowed 4 bits from the host portion. So using the formula, we do 2 to the power 4 is equals to 16. So we have 16 subnets. Okay, now let's put these formulas to work. Here's our problem. Subnet the network 192.168.10.0/24 into 4 subnets. Step 1, how many subnets do we need? Which is 4. So we need to borrow 2 bits because 2 to the power of 2 is 4. So we need to borrow at least 2 bits from the host portion. So n, it means 2, right? Now we know we have 2 bits to borrow, right? So the prefix length or subnet mask is 24 plus 2, which are borrowed bits, is equals to 26. Now, how many hosts does each subnet support? We have 32 minus 26. So because we use /26, so in total there are 32 bits. So 32 minus 26 is 6 host bits. So using this formula 1, 2 to the power 6 minus 2 is 62 usable hosts. Okay, now we need to find the block size. So for a /26, the subnet mask is 255.255.255.192. So the block size is 256 minus 192, that is 64. So we have 64 addresses in each subnet, and in total we have 4 subnets. That's what the requirement of this question was. Now you see .0 to .63 is subnet 1, .64 to .128 127 is subnet 2, 128, 191 is subnet 3, and dot 192 to 225 is subnet 4. Okay, now using this example, we can create a full subnet table. Okay, so we have 4 subnets of /26. Subnet 1 starts from /.0 to .63, and the first IP is reserved for the network, and the last is for broadcast. So we have 62 usable hosts. That starts from .1 to .62. Similarly, in second subnet, we have .64 to .127, and both of these cannot be used as hosts. So .65 is a host, first host, and .126 is the last host, and so on. Now let's talk about something you'll encounter in real world and definitely in CCNA questions. VLSM, variable length subnet masking. The problem with what we just did is dividing a /24 into 4 equal /26 subnets is that all 4 subnets are the same size, but in real networks, different segments, they need different number of hosts. Look at the comparison on screen. With fixed subnetting, if LAN 1 or LAN A needs 50 hosts, you give /26, which supports 62. That's fine. But if LAN B only needs 10 hosts, you give it /26 2, and 52 addresses are wasted. And if LAN C needs just 2 hosts for point-to-point link, you're wasting /60 addresses. That's inefficient. And you're dealing with scarce public IP address, and every address matters. So VLSM solves this by letting you use different prefix lengths for different subnets. For example, if LAN A gets /26, 62 hosts, perfect. But LAN B gets /28, which is 14 hosts, which is more than enough. LAN C gets /30, exactly 2 usable hosts for point-to-point link, no wastage. The key rule for VLSM, always subnet the largest requirement first. Get that out of the way, and then carve up the remaining spaces for smaller subnets. So work from the biggest to the smallest. Alright, let's arm you with some quick tools for the exam day. Cheat sheet on the left, just memorize this. /24 means 254, /25 means 126 /26 62, /27 is 30, /28 is 14, /29 is 6, and /30 is 2. Now let's run through the practice problems to the right. How many hosts in a /27? So /27 is 5 host bits, because 32 minus 27 is 5. So 2 to the power 5 is 30. 30 minus 2 is 2 to the power 5 is 32. 32 minus 2 is 30. Now divide 10.0.0.02/8 into 16 subnets. So how many networks, how many bits we are borrowing? We're borrowing 8 bits, right? So 2 to the power 8 is 256 subnets. What's the broadcast address of this 192.168.5.64/26? So in in previous examples, we know that /26 has the block size of 64. That means the subnet starts from .0 to .63 and then .64 to .127. So this subnet 192.168.5.64, this IP address lies in the second subnet. So that's why the second subnet has the broadcast address of .127. I can show you in the what we did in the subnet table. So this is the subnet I'm talking about. So the broadcast address is 127. Now, how many subnets fit in /24? So /24, which means we have 6 bits that we have borrowed from the host. So 2 to the power 6 is 64. So 64 subnets. And that's it. You have just completed a subnetting tutorial from scratch. Let's do a quick recap for everything you have learned today. What subnetting is and why every network engineer needs to understand it. IP addresses, the classes, how CIDR notation works, how subnet mask divides an IP address into network bits and host bits. The two formulas that we learned, 2 to the power h minus 2 and 2 to the power n, which means the first formula is for the number of hosts and the second is number of subnets. Step-by-step walkthrough of subnetting using real-world examples. VLSM for efficient right-size subnetting. If you made it so far, you are already ahead of a lot of CCNA candidates. The next step is to practice. Try to subnet a new network every day. Do the math by hand before checking the answers. That's how you build muscle memory you need for the exam. Okay, that's it. Good luck on your CCNA journey. Like and subscribe to the channel. Thank you.